Hi students, today I am going to discuss about the number of onto functions. In the previous video, we discussed the principle of inclusion and exclusion. With the extension of that, let us go for the number of onto functions, which is important for IIT JEE mains as well as advanced. Now, first of all, what is an onto function? For example, a function f mapping from a to b. Any function f mapping from a to b is said to be an onto. Every element of b has at least one pre-image in a. That means what? Every element in the set b should have some correspondence with set A. That means again, in other manner I can say that the range is equal to codomain. No element should left blank in the second set. That means again range is equal to codomain. Now for example, let us consider set A having m elements and set B having n elements. For example, A1, A2, A3, so on, Am. M elements are there in set A. Similarly, B1, B2, B3, so on, Bn. Now clearly, n of A is equal to m, n of B is equal to n. Now, I am going to find out how many such number of onto functions exist. For that, the basic criteria is the number of elements of set A should be greater than or equal to number of elements of set B. That means what here? M should be greater than or equal to n. What happened if m is less than n? The question arises. For example, let us take. For example, this is A1, A2. Set A containing. Set B, B1, B2, B3. Set A has 2 elements, whereas set B has 3 elements. According to this, m is less than n. If I map like this, A1 to B1, A2 to B3, definitely this is not an onto function. Why? Because every element should have at least one pre-image in set A. Yet the element B2 has no correspondence with any one of the elements in set A. Hence, if number of elements in A is less than in B, then number of onto functions becomes 0. That means there will be no such onto functions mapping from A to B when that m is less than n. Now coming to the point, m greater than or equal to n. M greater than or equal to n. Now, my dear students, here total number of functions is nothing but number of into functions plus number of onto functions. Yes. Now again the new word came. What is into function? A function which is not onto is called as into. A function which is not onto is called as into. Now, to find the number of onto functions, total number of onto functions is nothing but total functions minus total number of into functions. Now, I am going to give you the explanation about that total number of functions as well as total number of into functions so that we get that number of onto functions. Come. Now again, function. In the previous videos also we know about that definition of a function and number of functions also there. But again, just consider, for example, a set A containing, example, let us take this. The set A containing m elements, whereas set B containing n elements, then total functions will be this element A1 can be associated with any one of the element in set B. That is the basic definition of a function. For every A belongs to A, for every A belongs to A, there exists unit B belongs to B. For every element A belongs to A, I mean A1 or A2 or A3 so on up to Am, there exists a unique element B belongs to B. Hence, for example, to get the number of functions, A1 can be mapped with either B1 or B2 or B3 or Bn. A1 can be mapped with either B1 or B2 or B3 or so on up to Bn. Therefore, A1 possibilities are there. For example, A1 can be done in how many ways, sir? N ways. Because A1 B1 or A1 B2 or A1 B3 or A1 Bn, there exist n cases will be there. Similarly, A2 also how many ways? N ways. A2 also n ways since Bn are there. Similarly, A3 also n ways. Understand? Therefore, Am also n ways. Hence, total number of functions will be n into n into n so on into n up to how many elements are there here? 1, 2, 3 so on up to m. Hence, this becomes m times, my dear students. Hence, the answer is n power m. Hence, a set A containing m elements and a set B containing n elements, then the number of functions from set A to set B is n power m. That is the formula for finding the functions. Therefore, this will be what n power m. You keep it like that. Understand? Now I am going for into function. Now, into function. Coming next. What is into? Which is not onto. Which is not onto. Rub this, okay? What is into? Which is not onto. That means, my dear students, here, if B1 is left, for example, that is also into function. Because B1 is left. B1 is not mapped with any one of the elements within set A. Obviously, one element is left means that is not an onto a function which is not an onto, nothing but into. Not only B1, also B2 also there. Both B1 and B2 will be there. Two elements are not mapped. Two elements have no correspondence at all with any one of the element in set A. Obviously, not onto function. That is called as into function. Now, my dear students, how to get such number of functions? For example, if B1 is not mapped with any one of the element in set A, that means A1 can be mapped with what? Either B2 or A1 can be mapped with what? Either B3, so on. Therefore, A1 can be assigned to any one of the element in set B in how many ways? Since we have left one element in the set B, out of n, one element is left, then n minus 1 ways. That means A1, B2, A1, B3, A1, B4, so on, A1, Bn. That can be done in n minus 1 ways. Now, similarly, A2, similarly, A3, similarly, An. Hence, if we, for example, if we leave one element in the set B for finding into function, if we leave one element that one element is not associated with any one of the elementary set A, then it can be done in n minus 1. See, n minus 1, n minus 1, so on, so on, so on. N minus 1 whole to the power of m. Now, my dear students, that one element I suppose here I have taken the B1. It need not be only B1. It can be B1 or B2 or B3 or so on to Bn. How many ways I can be able to leave one element? Such numbers are there, n elements are there. That means that is selecting one element out of n. That in the ways of nc1 into n minus 1 whole to the power of m. nc1 into n minus 1 whole to the power of m. What exactly it means? Again I am telling you, my dear students. It means that which is not onto means the function is into. Into means either 1 or 2 or so many up to n should be left in the second set. That means no mapping with the first set. That means if I take 1, this n minus 1, if I take any one of the, I want to leave one element out of n, it can be done in nc1 ways. And remaining all elements can be mapped with the set B in such a ways, how many? N minus 1 ways. Power m ways. N minus 1 power m. Now, either B1 or 2, na? It can be 2, not only 1, it can be 2. Or it can sometimes 3. Again, it can be 4. Because only one element I map, up to all are left, that is also into function. If 2 elements are also left, that is also into function. If 3 elements are left, that is also into function. Now, I had only condition for only one element which is left in the set B. Now, yesterday we discussed, last class we discussed n of A1 union A2 union so on union AN, the principle of inclusion and exclusion. What is that? Sigma n of AI, I running from 1 to n. If you see the previous video, it will be helpful for this video for finding a onto function. Minus sigma n of AI intersection AJ 1 less than or equal to I less than j less than or equal to n, plus so on minus 1 whole to the power of n minus 1 into n of A1 intersection A2 so on AN. This is the formula for principle of inclusion-exclusion. Why I taken the principle of inclusion-exclusion in onto function means, beta, here in set B we have n elements are there. We can leave one element or 2 elements or 3 elements or up to n minus 1 elements. That means what? That is onto function. Sorry, it is not onto function. That means if I left only one, this is the case is there. If I left 2, we'll get, for example, we'll leave these 2. That means again what happened here? Here this is 1 and this is 2. What happened here? If we want to remove these 2, I mean remove in the sense there is no mapping with that. This A1 can be done in out of n, we have removed 2 elements, remaining how many will be there? N minus 2 elements will be there. N minus 2 elements will be there. Now, here A1 can be mapped with any one of these elements n minus 2 ways. Again A2 n minus 2 ways. Again A3 n minus 2 ways. So on to AM n minus 2 ways. Therefore, A1 n minus 2, A2 n minus 2, so on, so on, so on. AM n minus 2 means total how many is n minus 2 whole power n. Now, here for assumption, I told that 2 elements we have not taken, I mean not mapped with any one of the in set A. Thus to be B1, B2 I told, but need not be B1, B2, B1, B2, B1, B3, B1 up to Bn, B2, B3, B2, B4. That means what? 2, selecting 2 out of n. It can be done in what? NC2. Now, what sign here will get, sir? Minus. Why? That is called that principle of inclusion-exclusion. That is nothing but principle of inclusion-exclusion. This is NC1, selecting 1, here selecting 2. Yesterday, I mean, in the previous video I told. Similarly, what we get next? Plus NC3 n minus 3 whole to the power of m. Next, minus NC4 n minus 3 n minus 4 whole to the power of m. So on. Again, this is the formula for finding what? Into function. This is the number of into functions, my dear students. Now the main agenda is what? Total number of onto functions. That means, therefore, total number of onto functions, nothing but total number of functions. See, total number of functions, that is n power m minus total number of into functions. NC1 n minus 1 whole to the power of m minus NC2 n minus 2 whole to the power of m plus NC3 n minus 3 whole to the power of m minus so on. Hence it will be n to the power of m minus NC1 n minus 1 whole to the power of m plus NC2 n minus 2 whole to the power of m minus so on. This is the generalized formula for finding number of onto functions. We can also write in summation form. And this number of onto functions plays a vital role in doing the problems from the chapter permutations and combinations. And this plays again an important role for IIT JEE, mains and advanced. Very easy, or interlinked functions and again with the permutations combinations. Today in this video we have derived that the number of functions, the number of into functions, the number of onto functions. If you see the previous JEE papers, especially mains papers, we'll get that we'll see the questions from this topic in any one of the 1 or 2 or 3 sessions. I hope you understand. Thank you.